Specific heat capacity. Here are the aims of the video. Know what specific heat capacity is and know how to use the equation for specific heat capacity. You'll be given this equation in your exams, but depending on which exam board you're sitting, you'll either use the letter Q or E for heat energy. Pause the video and have a look. The amount of heat energy or thermal energy stored in a substance depends on three factors: its mass, its temperature, and the specific heat capacity of the material. You'll see these three factors in the equation we use to calculate thermal energy. In GCSE Physics, we're often interested in knowing how much the thermal energy has changed. So here's the equation we use. Change in thermal energy in joules equals mass in kilograms times by specific heat capacity in joules per kilogram per degree Celsius times by change in temperature in degrees Celsius. As I said in the introduction, depending on what exam board you're sitting, you'll see heat energy represented by either the letter Q or E. Both are fine, but I'll be using Q rather than E for the rest of the video. The triangle symbol is a Greek letter of the alphabet pronounced delta. It's the symbol we use to mean change in. The wiggly zero is another Greek letter of the alphabet pronounced theta. We use it to represent temperature. Delta Q equals mc delta theta. That's the easy way of saying the equation. I've rearranged the equation to show you how to work out the mass, the specific heat capacity, and the change in temperature as well. Plus, I've put the equation for change in temperature up there as well, because that's useful for some of the questions you could get asked. If you're making notes, make sure you pop them in your book. Mass is the amount of matter there is in an object. Temperature is related to the average kinetic energy of an object's particles. And the specific heat capacity of a substance is the amount of energy required to raise the temperature of 1 kilogram of the substance by 1 degree Celsius. How does heat energy affect the temperature of a substance? Do you know that different substances need different amounts of energy to heat them up? The specific heat capacity, C, is a good indication of how quickly something heats up and cools down. The smaller the specific heat capacity, the quicker the substance can heat up and cool down, and the bigger the specific heat capacity, the slower it heats up and cools down. This table shows how much energy is needed to make 1 kilogram of different substances heat up by 1 degree Celsius. The table shows if we put 450 joules of energy into a 1 kilogram block of iron, its temperature would go up by 1 degree. However, we need to put 900 joules of energy into a 1 kilogram block of aluminium to make its temperature go up by 1 degree. Water has a very high specific heat capacity and needs 4,200 joules of heat energy to make 1 kilogram of water heat up by 1 degree. That's nearly 10 times more energy than iron needs. That's why when you boil the kettle to make a cup of tea, you should only use as much water as you need for your brew, or you're wasting a lot of energy and money. Here's an example to help you understand. If you put 900 joules of energy into a 1 kilogram block of iron, how much would its temperature go up by? The answer is 2 degrees, because the specific heat capacity of iron is 450 joules per kilogram per degree C, which means if you put 450 joules of energy into a 1 kilogram block of iron, then its temperature will go up by 1 degree. We are putting 900 joules of energy into a 1 kilogram block, which is twice as much energy as it needs, so its temperature will go up by 2 degrees, not just 1. Here's a couple of questions for you to try to make sure you understand. Pause the video and have a go. And here's the answers. So, we can conclude that the more heat energy you put into a substance, the more the temperature rises. Pretty obvious, really. Let me check your understanding about how mass affects the temperature rise. The specific heat capacity of iron is 450 joules of energy per kilogram per degree C. So that means if you've got a 1 kilogram block of iron and put 450 joules of heat energy into it, the temperature would go up by 1 degree. It's really important to understand the units. Imagine we have a 2 kilogram block of iron. If we put 450 joules of energy into that, its temperature would only go up by half a degree because we've got twice as much mass to have to heat up. Understanding the units for specific heat capacity is the key to understanding specific heat capacity itself. Here's some questions to try to make sure you understand. Pause the video and have a go. And here's the answers. Pause the video and check them. So, we can conclude that the greater the mass of a substance, the smaller the temperature rise for a given amount of heat energy. Let me show you some different types of questions you might get asked in your physics exams, and I'll show you how to answer them. I'll use a temperature time graph to help you visualise what's going on. Let's imagine you've got a 2 kilogram block of iron. The block is heated from 20 degrees C to 70 degrees C. How much heat energy must the block have gained? Right, first write out the equation. Then write in the numbers with units. Then calculate the answer with units. Please note, the heat energy gained gets transferred into kinetic energy of the particles because the temperature rose. See my video about internal energy. There's a link at the top of the screen now, and there'll be another at the end of the video. Here's another example. This time we've got 1.5 kilograms of water and it cools from 90 degrees C to 10 degrees C. Calculate how much energy the water loses. First write out the equation, then write in the numbers with units, then calculate the answer with units. Please note, the amount of heat energy lost equals the amount of kinetic energy lost by the particles because the temperature dropped. Remember, kinetic energy is related to temperature. See my video about internal energy at the end of this video if you haven't watched it already and you want to learn more. Here's a few similar questions for you to try. Pause the video and give them a go. And here's the answers. Let me show you some different example questions you might get asked in your physics exams based on this equation, and then you can try a few. 2 kilograms of water is heated from 20 degrees C. The water receives 84 kilojoules, so that's 84,000 joules of heat energy. What is the final temperature of the water? First, we need to rearrange the equation to work out the change in temperature. Put the values in, and the change of temperature comes out as 10 degrees Celsius. But that's not the final temperature, that's the change in temperature. So what we need to do next is you can also work out the change in temperature equals the final temperature, take away the starting temperature. Let's rearrange that equation so we can work out the final temperature. Final temperature equals starting temperature plus the change in the temperature. So the starting temperature was 20 degrees C, the change in temperature was 10 degrees C, add them together, comes out as 30 degrees C. That's your final temperature. I've seen those questions catch people out before, so make sure you understand what I've just done. Here's your last example question. Calculate the mass of an aluminium block if 450 kilojoules, so that's 450,000 joules of heat energy heats it from 30 degrees C to 130 degrees C. Pause the video and see how to calculate the mass using this equation. Here's some questions for you to try. Pause the video and give them a go. And here's the answers. Thank you very much. I hope that video was useful and the animations help you to understand your physics better. Subscribe to my channel if you want to learn more, bang that bell all over the place, smash that like button while you're at it, and apart from that, work hard, be nice, and bye for now.